Hi everyone, this is Rick. Today I'll show you how to use SmartSlice to find the best build orientation for your 3D printed part. There are several considerations when it comes to selecting a build orientation, such as surface finish, print time, dimensional accuracy, and strength. The focus of this video is on how you can use SmartSlice to find the part orientation that results in the strongest part. Before I get to the demo, it is worth taking a few seconds to understand why the strength of a 3D printed part is dependent on the build orientation. The reason is actually very simple. Parts manufactured using the FFF method are printed in layers. As a new layer is extruded, it gets laid down on top of existing layers, and as long as temperatures are high enough, the new layer will form a bond with the old layer. The problem is that in most cases, the strength of this bond is less than the strength of the material itself. This is the well-known Z-direction strength effect. This means that if we print a simple cube, like we see on the screen, the strength of the cube in the Z or layer direction will be less than the strength of the cube parallel to the print bed. Let's take a look at a part. This is a simple arch, and the proper build orientation for this part is on the side, and that is obvious and intuitive. When printed on the side, the factor of safety computed by SmartSlice is 1.28. When I change the build orientation to an upright position, the factor of safety is only 0.92. This is a 28% reduction in strength, and that is when the part is printed with ABS. How about we run the study again, but use PPGF30, which is a material that is much stiffer and stronger than ABS. Comparing SmartSlice results again, we see that the part printed on the side is 80% stronger and an incredible 11 times stiffer compared to the upright part. Each of these 4 simulations took about 1 minute to complete, so in less than 5 minutes we virtually prototyped what would have taken about 15 hours to print and test. Now let's consider a part where the best build orientation is not so intuitive. This is a fixture, and there are 3 build orientations that make sense: standing upright, laying flat, and on the side. Which build orientation gives us the strongest part? To start, I need to select the anchor surface and define the loads. And I'll define a target factor of safety of 2 and a max displacement of 1 mm. Then I'll run a validation for each build orientation. Each validation takes about 2 minutes to complete. First is the upright orientation, which has a factor of safety equal to 1.78. The factor of safety for the flat orientation is 1.45, and the factor of safety for the side orientation is 1.58. The upright orientation is the best choice here. It is 23% stronger than the flat orientation and 13% stronger than the side orientation. Returning to the upright orientation, the factor of safety is still less than the target. At this point, you would run an optimization and let SmartSlice automatically find the print settings that result in a part that meets the strength requirement. Again, the total time spent in SmartSlice was only a few minutes. Compare this to the hours it would take to print and test actual parts, and it becomes clear that SmartSlice can quickly take the guesswork out of configuring your FFF parts.